Hello and welcome to today's episode. In today's episode, we will discuss qualitative methods of demand forecasting. I am Dr. Arshia Hussain, PhD in Human Resource Management and teaching in Jamia Millia Islamia University, New Delhi. So, let us start with the second method of or technique of demand forecasting, that is the quantitative method, also known as statistical methods. Subjective methods or quantitative methods has some limitations such as the element of bias, time and cost of collecting information and uncertainty of accuracy. Therefore, the firm should use these methods only when past data is not available, as in the case of new products, new price and new market. However, when past data is available, it is advisable that firms use statistical tools as they are more scientific and cost effective. These techniques depend upon time series of past sales. The following are the statistical methods. First one is trend projection methods. They are further classified into graphical method, trend fitting or least square method, and the third one is Box-Jenkins method. The second one is barometric methods. Under barometric methods, we have two methods. The first one is lead lag indicators and second one is diffusion indices. The third method is econometric methods. Under econometric methods, we have two methods. The first one is regression methods and the second one is simultaneous equations method. So, we will discuss the first one first of all, which is trend projection method. Trend projection is also known as classical method. It is a powerful statistical tool used to predict future values of a variable on the basis of time series data. Time series data are arrangement of the values of a variable in chronological order of days, weeks, months, quarters or years. The basic assumption in using time series is that past trend is likely to continue. In most time series data, we see phases of fluctuation in the values of the variable over time. This can be explained with the help of the following components of the time series data. The first one is secular trend. It refers to change occurring consistently over a long time. It is relatively smooth in its path. For instance, sale of personal computers may show an increasing trend over the years, while demand for jute products may show a declining trend. Second one is seasonal trend. Now, this refers to seasonal variations of the data within a year. For example, demand for woolens, ice cream, raincoats are dependent upon weather and would vary during a period of 1 year. The third one is cyclical trend. Cyclical trends are cyclical movements in the demand for a product that may have a tendency to reoccur in few years. These changes may push economic activity either in expansion mode or in a recession mode. The fourth one is random events. Random events occurs randomly. That is, these events have no trend of occurrence and they create random variation in series. For example, natural calamities, social unrest, foreign aggression, creating war-like situation and so on. Now, let us have a look at the merits and demerits of trend projection method. First of all, merits of trend projection method. The first one is trend projection method is simply to apply. The second one, trend projection, is quite reliable in forecasting demand. Now, demerits of trend projection method. The first one is the accuracy of trend projection method depends on the availability of time series data. The longer the series, the better would be the results. There may be an element of subjectivity in trend projection by geometric method. This method cannot be applied to forecasting for new as well as recently launched products where past data is not available. It may not necessarily be true that past pattern would be continued in the future as well. Now, we will see methods of trend projection. The first method is graphical method, second one is least square method, and the third one is Box-Jenkins method, which is we say for this method is APJMA. Now, we will have a look at the first method, which is graphical method. Now, in graphical method, the past values of the variable are shown on the vertical axis and time on the horizontal axis. The available data is then plotted on a graph and a line is drawn through all the points. Thereafter, the movement of the series is assessed and future values of the variable are forecasted. The method is very simple. It provides a general indication and fails to predict future demand. Next is least squares method. Least squares estimation is a powerful tool to estimate the coefficients of a linear function. It is based on the minimization of squared deviations between the best fitting line and the original observations given. In this method, which is also regarded as the algebraic method, we fit the data on demand and time in the form of equations and then project the demand for the future period. These questions are termed as normal equations, and the task of least square method is to find out the values of the coefficients in these equations. The equation for the linear trend is given as y is equal to a plus bx, where a is the intercept of the demand curve, b is the slope of the curve, which is also termed as the regression coefficient, and x is the deviation from mean of independent variable, that is time in this case. The normal equations in this model would be least squares estimation is based on the minimization of squared deviation between the best fitting line and the original observations given. Sigma y is equal to NA plus B sigma x. Sigma xy is equal to A sigma x plus B sigma x square. Now, in order to solve these trend equation, we need to solve equation number 1 and equation number 2 by the principle of least squares. The values of the coefficients as obtained on solving the normal equations are, now the equation is A is equal to y minus bx or y minus y bar into x minus x bar divided by bz into x square. Once the coefficients of the trend equation are estimated, we can easily project the trend for future periods. Least squares estimation is also used extensively to estimate regression equations. We will solve one illustration on the method of least squares. Now, we will have a look at the illustration. Forecast the trend of demand for cellular phones manufactured by Alpha Mobiles Private Limited for the next 5 years on the basis of the time series given. Now, we can see the number of years given to us. Number of years is 2011, 2012, 2013, 2014, 2015. Now, demand for each year is given to you in lakhs. For the year 2011, it is 120. That is 1,20,000. Then for the year 2012, it is 1,40,000. Then it is for the year 2013, it is 1,20,000. Then for the year 2014, it is 1,50,000. Then for the year 2015, it is 1,80,000. Now, we can see the solution. There are various columns given to you. In the first column, years are given to you. In the second column, we have demand, which is represented by y. In the third column, we have x. Then deviations are given to you in the next column, and similarly we have x square and xy. Now in the years we have 2011, 2012, 2013, 2014, 2015. Now the demand for each year is given to you as 120, 140, 120, 150, 1 lakh 80,000, which is in lakhs. Now that is a column of y. Now next column we have x, which is 1, 2, 3, 4, 5, and that is for the number of years given to you. And the next column is of deviations, which will be found by putting the formula, that is y is equal to y minus y bar. So for the first year we will get minus 22. For the second year, which is 2012, we will get minus 2. For the third year, that is 2013, we will have minus 22. Then for 2014, we will have 8. 2015, we have 38. Now the summation of all these will give us sigma y, which will be 0. Similarly, sigma x in the previous column we have 15, and the mean values, which is represented by x bar, is equal to 3. The demand total is sigma y, which is equal to 710, and mean, which is represented by y bar, is equal to 142. Now we will see the next column, which is deviations in x, which is calculated the same way we have calculated the deviations in y. The formula for calculating this is x is equal to x minus x bar. So for the year 2011, we will have minus 2. For the year 2012, we have minus 1, then we have 0, then we have 1, then finally for the year 2015, we have minus 2. Now the summation of all this will give us 0, which is we say that it is sigma x is equal to 0. Now x square, again we can see x square will be for the year 2011 is 4, then 1, then 0, then 1, 4, and the summation of all this, which is represented by sigma x square, is equal to 10. Now next column we have xy, so we will multiply x and y, and which gives us a figure of 44 for the year 2011. Then for the year 2012 we have 2, then for the year 2013 we have 0, then for the year 2014 we have 8, then finally for the year 2015 we have 76. Now summation of all this, which is sigma xy, is equal to 130. The equation for the linear trend is given as y is equal to a plus bx. Now in order to solve this trend equation, we need to solve the following normal equations. Sigma y is equal to na plus b sigma x. This is the first equation. The second equation is sigma xy is equal to a sigma x plus b sigma x square. Now solving the normal equations, we get a is equal to 103 and b is equal to 13. Now the equation for the linear trend is y is equal to a plus bx. Hence the equation for linear trend is y is equal to 103 plus 13x. Now let us calculate the trend values for the next 5 years on the basis of this equation as, so for the year 2011, the equation would be y is equal to 103 plus 13 multiplied by 11, which gives us the answer of 246. Similarly, for the year 2012, we have y is equal to 103 plus 13 multiplied by 12, which is equal to 259. Then for the year 2013, we have y is equal to 103 plus 13 multiplied by 13, which gives us the figure of 272. Then for the year 2014, we have y is equal to 103 plus 13 multiplied by 14, which gives us a figure of 285. Then lastly, we have for the year 2015, that is y is equal to 103 plus 13 multiplied by 15, which gives us a figure of 298. Now the next method is Erima method. Erima method stands for the auto-regressive integrated moving average method. It has been given by Box and Jenkins. Therefore, the method is also known as Box-Jenkins method. It is considered to be the most sophisticated technique of forecasting. It combines moving average and auto-regressive techniques. Here, we shall provide you an insight into the steps involved in this method. An autoregressive equation expresses the variable to be forecasted as a function of its own lagged value. For example, sales of next year forecasted as a function of sales of past 5 years. Now, the first one is autoregressive model. In a general autoregressive model, the behavior of a variable in a period is linked to the behavior of the variable in future periods. The general form of the autoregressive model is y is equal to a1 y t minus 1 plus a2 t minus 2 plus it continues till a n y t minus n plus e t. Now, this model explains the value of y in period t depends on the value of y in periods t minus 1, t minus 2 till to the period t minus n. The term et is the random portion of yt. Yt is not explained in this model. Now, we will move on to the next model, which is moving average model. The moving average model estimates yt in relation to residuals et of the previous years. There are two types of moving average methods. The first one is simple moving average method and the second one is weighted moving average method. First of all, we will talk about simple moving average method. The simple moving average was more popular before the emergence of computers because it is easy to calculate. But with the development of technology, processing power has made other types of moving averages and technical indicators easier to measure. It is calculated from the average closing prices for a specified period. A moving average typically uses daily closing prices, but it can also be calculated for other time frames also. Other price data such as the opening price or the median price can also be used. At the end of the new price period, that data is added to the calculation while the oldest price data in the series is eliminated. Using a simple moving average model, we forecast the next values in a time series based on the average of a fixed finite number m of the previous values. Thus, for all I which is greater than m, we have y is equal to 1 upon m sigma y I, which is equal to y I minus m plus it continues till the n number of years, that is plus y I minus 1 divided by m. Next, we will discuss weighted moving average method. Now, the weighted moving average method is a tool that is used by the traders to know the general direction of trade. On the basis of the trade direction, they make their decision to sell or buy. It assigns greater weighting to recent data points and less weighting on past data points. The weighted moving average is calculated by multiplying each observation in the data set by a predetermined weighing factor. Using the weighted moving average to determine trend direction is more accurate than the simple moving average, which assigns identical weights to all the numbers in the data set. The method of moving averages is a simple method involving the calculations of moving averages for a 3-year period or a 4-year period to find out the trend. Now, this is explained in the following table. Now, we will see the table which shows 3 yearly moving totals and 3 yearly moving average trend. The years are given to you from 2011 to 2016. And the quantity demanded is also given to you, that is 1000 for the year 2011, then 1200 for 2012, then 1400 for 2013, 1600 for the year 2014, then 1500 for the year 2015 and 2000 for the year 2016. Next column is 3 yearly moving total. So, in the first we will write nothing because as there is no moving totals, and for the second one we write 3600. Then for the year 2013 we will write 4200. Then for the year 2014 we will write 4500. Then for the year 2015 we have 5100. Now, 3 yearly moving average trend. So, for the first one there is nothing, but for the second year, that is 2012 year, we have the average is 1200 and 1400 average for the year 2013, then 1500 moving average for the year 2014, and finally 1700 for the year 2015. Now, in the table we have assumed that the firm wants to calculate 3 yearly moving average. So, first the firm calculates the moving total for the first 3 years, that is for 2011, 12 and 2013. So, we have 1000 plus 1200 plus 1400, which is equal to 3600. Now, the average for these 3-year period is 1200. Second, the firm calculates the moving total for the next 3 years, which is for the year 2012, then for 2013, then for 2014, and the figures we have will be 1200 plus 1400 plus 1600, which gives us a total of 4200. And the average of these years is 1400. So, thus the firm calculates the moving average or the trend of demand, which is plotted on a graph with the horizontal axis representing the years. So, from the graphical years, demand forecasting is projected through the extension of the curve for the years ahead. Next, we will discuss the barometric techniques. Barometric technique of forecasting indicates the general trend in overall economic activities. This method can nevertheless be used to forecast demand prospects for a product, not the actual quantity expected to be demanded. For example, allotment of land by DDA to the group housing societies, which is a lead indicator, and it indicates higher demand prospects for building materials, cement, steel, bricks and so on. Barometric models usually search for patterns among different variables over a period of time. Thus, the focus is on finding historical series whose direction would correlate with the series to be predicted. Under this method, an index of relevant economic indicators is conducted and constructed to forecast future trends on the basis of movements in the index of economic indicators. The indicators used in this method are classified as, first one, leading indicators, second is coincidental indicators, and the third one is lagging indicators. Leading indicators are the indicators which move up or down ahead of some other series. Leading indicators tell us where we are heading. Coincident series moves up or down simultaneously with the level of economic activities. That is, they go down at the peak and go up at the trough. Coincident indicators tell us where we are. Lagging indicators moves with economic series after a time lag. That is, they go down after the peak and go up after the trough. Lagging indicators tell us where we have been in the past. For instance, interest rates are leading series and demand for loan is lagging series. Now, the concept of leading and lagging indicators is very much like the law of demand, as they can predict the direction of a future change, not its magnitude. They cannot also precisely tell when the change would finally reach the economy. So, leading indicators have often given wrong signals in the past and thereby failed to alert for a forthcoming recession. Leading indicators can be used as inputs for forecasting aggregate economic variables or gross national product, that is GNP, or aggregate consumers expenditure or aggregate capital expenditure and so on. Now, we will see merits of barometric techniques. Now, this method aligns macro with microeconomics. The second merit is it is less costly as it depends on past data. Next is demerits of barometric techniques. The first one is the selection of a proper choice of indicators series may pose as a major problem. Second, this method can be used only for short-term forecasting. Now we will see econometric methods. Econometrics may be defined as the social science in which the tools of economic theory, mathematics and statistical inference are applied to the analysis of economic phenomena. Econometric methods apply statistical tools on economic theories to estimate economic variables. An econometric model consists of a system of simultaneous equations or maybe a single equation estimated from past data that is used to forecast economic and business variables. In fact, econometric models are considered to be more reliable in forecasting demand than other methods discussed so far because of the fact that these models largely deal with causal relations. As such, econometric tools, multiple regression techniques and multiple equation models are being increasingly used by firms in demand forecasting. Now, there are two methods which are popularly used under econometric methods. They are the first one, regression method, and second one, simultaneous equation method. Now, before discussing regression method and simultaneous equation method, let's first have a look at the advantages of econometric methods. Now, as far as advantages are concerned, the first advantage is econometric model explains and forecasts an economic phenomenon. It establishes causal relationships between economic variables. The second one is it enables us to not only forecast the direction of change in an economic series, but also the magnitude of change. Thus, it helps to explain the turning points in economic series. Econometric method is an improvement over a trend projection technique which is unable to identify the turning points. It is also the improvement over the barometric models which are incapable of predicting the magnitude of expected changes. Next is econometric technique helps to measure the elasticity of various determinants of demand such as price elasticity, income elasticity, advertising elasticity and cross elasticity of demand. Econometric model may be single equation model or a multiple equation model. Now, single equation model is widely used in empirical demand analysis. In single equation model, we estimate the parameters, that is the coefficients of demand equation, and then use these parameters to forecast the future demand for a product. Single equation demand model. First of all, economic theory tells us the demand for a commodity is a function of its own price. Disposable income of the people, prices of related commodities, advertising expenditure. Thus, we can say the demand model in an equation of linear form which is generally used to forecast future demand is QD is equal to A plus B1 Px plus B2 Pc plus B3 Y plus B4 AD, where Px stands for own price of a good X, Pc stands for price of a competitive good, Y stands for disposable per capita income of the people, and AD is advertising expenditure by the firm. Now, A is constant term, B1, B2, B3 and B4 are the coefficients of the various independent variables. Now, we will discuss the methods of econometric models, that is regression method. First of all, regression method. Regression analysis method is the most popular method of demand forecasting. This method combines economic theory and its statistical techniques estimation. Economic theory helps to specify the determinants of demand and to determine the nature of the relationship between the demand for a product and its determinants. It helps in determining the general form of demand. Statistical techniques are employed to estimate the values of parameters in the estimated equation. This method establishes a relationship between the dependent variable and the independent variables. Thus, in this case, the quantity demanded is the dependent variable, and income, the price of goods, the price of related goods, the price of substitute goods, and so on are independent variables. The regression equation is derived assuming the relationship to be linear. Regression equation is y is equal to a plus bx, where y is the forecasted demand for a product or service. Now, next method we will discuss is simultaneous equation method. Simultaneous equation method establishes mutual dependence among variables. This method is based on the principle that in any economic decision, every variable influences every other variable. For instance, quantity demanded of tea depends on price of coffee, and price of coffee in turn will be influenced by quantity demanded of tea. Now, given such simultaneous and two-way relationships, it would be difficult to establish a relationship if we construct and use single equation models of demand, though that is the conventional method. The most serious limitation of the single equation model is that attention is focused on a single equation. So, therefore, to ensure more realistic solutions to economic relationships, simultaneous equations method gives due recognition to the element of mutual dependence among variables. There are two types of variables that are included in this model. The first one is endogenous variables and the second one is exogenous variables. The first one is endogenous variables. The variables that are determined within the model are called endogenous variables. In other words, endogenous variable is a variable that depends on other variables in a statistical or economic model. These are also called controlled variables. If the value changes for an endogenous variable, it is because there are changes to its relationships with other variables in the same model. Therefore, it is similar to a dependent variable because both are influenced by one or more independent variables. Next is exogenous variables. Now, exogenous variables are those that are determined outside the model. It is just opposite of an endogenous variable. It depends on external factors outside the model. So, it is not impacted by variables within the model. In real life situations, however, some variables may not be entirely endogenous as it can be influenced by factors both external and internal to the model. Therefore, variables are often partly endogenous and partly exogenous. For example, time, government spending and weather conditions. These variables are determined outside the model. So, that is all for today. Hope you have understood the quantitative methods of demand forecasting. So, we will meet in the next episode. Till then, take care. Goodbye.